Hello and welcome to another one of D's ADD videos. Today we're going to be discussing some basic examples of inequalities. Well, if they're linear, meaning the highest power of x is a 1, like this one is here, if there's nothing there it's understood to be a 1, you can just solve it outright. So subtract the 8, do the opposite of how it's connected to the x, and then you're going to get 4x is less than 4. And divide both sides by 4, and then you get x is less than 1. If you were to draw that on a number line, there is no y, so there's no point in drawing a y-axis. You would have a 1 with an open dot because, here, let's do that a different color, because that open dot is because there's no equal sign there, it's just a less than. And less than means to the left of, smaller than. If you have trouble with that, the way I remember it is that the smaller point here points to the smaller value. So this is saying x is smaller than 1. The bigger part points to the bigger part number. So if I was doing interval notation here, that would be negative infinity, comma, 1, parentheses, parentheses, because this is an open dot. Had it been a closed dot, that would have been a closed bracket, a rectangular bracket. Let's look at this one here. Same scenario, solve for x. Now, watch out. Anytime you divide or multiply by a negative number, the direction of your inequality changes. You do that anytime it's a division or multiplication, or if you flip both sides. So your number line, here's your negative 6. This time we're going to get a closed dot, and we're going to be greater than, x is larger than negative 6. So when we're doing our interval notation, oops, sorry about that. Alright. Now this one, the highest power of x is not 1, it's a 2 there. So we have to use sign analysis. If you remember from the concept video, you have to find what are called cut points by setting that off equal to 0. If you factor by grouping is fine. In this case, it's not that complex. You don't really need it. So if you were to set those individually equal to 0, you would get the 2 points of negative 3 and positive 5. Note that there's an equal sign there, so we do get closed dots there for both those values. And now what you do is you do a test point. Plug in a point to the left and the right of each of those into your equation. So when I plug in a negative 4, I don't care about the actual value, just the sign. Negative 4 minus 5 is negative. Negative 4 plus 1 is negative. Two negatives times each other give you a positive. So everything to the left of negative 3 is positive and above the axis. That's what that means. So then when I plug in a 0, I get negative 5 times positive 3 is a negative number. So everything between these two numbers right here is a negative, or below the axis. And then when I plug in a 6, I get two positive numbers multiplied together, and that's a positive. Okay. My question here was asking me, where is it greater than 0? Mathematically, that is positive. So that would be from negative infinity to negative 3, and always a parentheses with the infinites. Oops, sorry about that. Then a bracket for the negative 3 because it's including it. Union 5 to infinity. Okay? There's that. I guess I haven't been circling my answers. And this is interval notation, using your parentheses and brackets. And then finally we're going to look at this fraction here. In the fraction, what you do is you set the top and the bottom equal to 0 to get your cut points. So in this case, if you just went off to the side and did it, it's fine. Subtract 12 from both sides, divide by 4, there's 1, and then that one's a little easier, you get 1, and you draw your number line. We're doing sign analysis because it's a fraction and an inequality. Anytime we have a fraction and an inequality, we have to do this. So we have a -3, positive 1, and then we're going to have open dots for both of these. And then here we have test points of -4, 0, and 2 is fine. So negative on top, negative on bottom gives me a positive value. So everything's above the axis. Don't let this plus sign down here make you think it's below the axis. Plus means above the axis. And then plugging a 0, you're going to get positive over negative, which is negative. And then plugging in a 2, you get positive. Okay. Again, the values don't matter, just the signs. So this question was asking for less than 0, right? So negatives. So what we would do is we would write -3, comma 1, and they both get parentheses. Okay. Why? Because that's where the negative sign showed up, and that's where it's less than 0. Okay. What was your clue that we needed sign analysis? Go back and watch the concept video if you forgot. But the main reasons are whenever your power of x is greater than 1 and you have one of these guys, inequalities, or if you have a fraction and an inequality. Okay? So if any of those scenarios show up, make sure you use your sign analysis. I hope I've clarified things a little bit with these basic examples. Make sure you check out the next video where they'll be a little bit more difficult. Practice, 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 most importantly. Thank you and have a nice day.